In today's lesson 8.5, we're going to talk about using intercept form. Now, the form's going to look a little different from the other two forms we've looked at, which was standard form and vertex form. In this form, we're going to have the intercepts. So let's take a look. So we've graphed quadratic functions in different forms. Now we're going to take a look at this one. So we call it intercept form because the intercepts are actually P and Q. Now, this will give me point P, this will give me point Q. Notice these are the x-intercepts where it crossed the x-axis. Now, when I go to find the vertex, that's going to be the average of these two. So we're going to add those up and divide by 2. Okay? Now, I know the graph's going to go up because A is positive. So let's put this into some actual numbers here. I want to graph this and then describe the domain and range. So the first thing we're going to do is identify the x-intercept. So P is 1. Keep in mind, this is negative, so what is P? 1. Q, negative, so that means this, in order for this to be positive, I need to have a negative 3. So I'm going to plot 1, 0, and negative 3, 0. So I've got 1, 0, negative 3, 0. Now I need to find the axis of symmetry. So I'm going to add 1 plus negative 3 divided by 2. So I have negative 2 divided by 2, which gives me a negative 1. So that means right here is my axis of symmetry. Now I need to plot the vertex. So the x-coordinate of the vertex is negative 1 because that is the axis of symmetry. So now to find the y-coordinate, I need to substitute negative 1 for x. So f of negative 1 is going to give me, looking up here, negative 1 minus 1 times negative 1 plus 3. So I have negative 2 times 2, which is going to give me a negative 4. So my vertex here is now negative 1, negative 4. So let's see, negative 1, these go by 2s, so this is negative 4. So now I can graph this better. It should look something similar to this. However, I still need to answer the domain and range question. Now, remember, the domain is the x value, and the range are the y values. So my domain can be any real number I want it to be. So we're going to say all real numbers. Now my range is what are my y values going to be? So if I look here, all my y's are going to be greater than negative 4. So y is greater than or equal to negative 4. Now, if you notice, this is not quite an intercept form. So I'm going to have to rewrite this. So if I look, I can factor out a 3. So that gives me x squared minus 1. So I have 3 times x plus 1, x minus 1. So my p is 1 and negative 1, meaning my points are going to be 1 and 0, negative 1 and 0. So let's see, 1 to 0, negative 1 and 0. So now my axis of symmetry, negative 1 plus 1 divided by 2. Let's see, that is 0 divided by 2. Yes, I can have 0 divided by a number, which gives me 0. So that means my axis of symmetry is x equals 0. So that is this point right here. But now I need to find the vertex. So I know it's going to be on 0 somewhere. So find the y-coordinate of the vertex and substitute 0 for x. Now I always want to go back to the original equation. So I have f of x equals 3 times 0 squared minus 3. Well, 0 squared is 0 times 3 is still 0. So I end up with my y equals -3. So my vertex is 0, -3. So let's say it's negative. Oh, you know what? I got to be careful here. Counting by ones on this case. And so let's see, that's -1, -2, -3. So I'm going to have a function that looks like this. So my domain is all real numbers. And my range, let's see, y has to be greater than or equal to -3. So now it is your turn. Go ahead and pause the video. When you're done, check your work. When I factor out, I get x plus 3, x minus 3. My x-intercepts are -3, 0, 3, 0. Axis of symmetry is 0. Replace x to get y, so my vertex is at 0, 9. My domain is all real numbers, and my range is y is greater than or equal to -9. All right, let's take a look at example 3, finding zeros. Now in 8.2, we learned that a zero of a function is an x value. Let's take a look at example 3, finding zeros of a function. So in 8.2, we learned that a zero of a function is an x value for which f of x is 0. We can use the intercept form here of the function to find the zeros of the function. So this is what we've done in the past. What makes this 0? Shown us that x equals 5 to 0, or I'm sorry, x minus 5 to 0, and x plus 7 to 0. So my zeros here are 5 and -7. So the zeros of the function here are -7 and 5. I don't want to put a comma there. I'm afraid you'll think that's a point. So, all right, find the zeros of the function. Write its function in intercept form to identify the zeros. So let's take a look. So we're going to factor here. So I'm factoring out a 2. So I have 2 times the quantity x squared minus 4, x minus 12. So 2x minus 6 times x plus 2. So I don't need to worry about this. So I know that, let's see, x equals 0 or 6, x equals -2. So my zeros here are 6 and -2. Now let's take a look at B. So when I factor this, we've got x minus 2. So difference of perfect squares. So that means I have x plus 5, x minus 5. So let's see, I have x equals 2, x equals -5, x equals 5. So the zeros here are 2, -5, and 5. It is your turn. Go ahead and hit pause, show your work, and then hit play to check your answers. Okay, so if I take a look at on your own or your turn number 2, your zeros are 6 and 1. It's already factored. For 3, we need to factor the difference of a perfect square. So we have x times the quantity x plus 1 times the quantity x minus 1. So we have x is 0, -1, and 1. So our zeros here are 0, -1, and 1. Let's now take a look at example 5, graphing a quadratic function using zeros. So we've got the formula x squared plus 3x minus 4. So this is in standard form, so we know that the y-intercept is -4, putting that at 0, -4. So we have 0, -4. Now we're going to use the zeros to plot the rest. So when I factor this, I get x plus 4, x minus 1. So that means my zeros are -4 and 1. So I have -4 and 1. Now from here, I can go ahead and sketch a parabola. But what I'm going to do is sketch a more precise graph. I'm going to pick some points here to kind of help me out. So I have x is -2, -3, and -1. So I'm going to replace -2. So let's see, we have h of x equals x squared plus 3x minus 4. So I have -2 squared plus 3 times -2 minus 4. So that's 4 plus -6 minus 4. So y equals -6. Go ahead and hit pause and find the y values for -3 and 1. Okay, so our values for our -3, -4, -1, and -6. So see, I have -2, -6, -3, -4. Oops, this is 5, I'm sorry. -6, -1, -6. So I'm pretty close. Now this is not going to be the, what the heck is wrong with this graph? So I went ahead and plotted these points. Next, I'm going to connect my points for a parabola. All right, go ahead. It is now your turn. Hit pause and graph your function. When you're done, hit play to reveal the answer. Let's now take a look at example 6, writing quadratic functions. So we've got the x-intercept, -1 and 5, and we now have the vertex, -2. So because we know the vertex, use the vertex form to write a function. So we have f of x equals a times the quantity x minus h squared plus k. So to make this a little bit easier, we're going to let a equal 1, okay? So now I've got 1 times x plus 3 squared minus 2. Remember, we're taking the opposite here. So that gives us x squared plus 6x plus 9 minus 2. So our function here is f of x equals x squared plus 6x plus 7. So given the points that indicate the x-intercepts are -1 and 5, we're going to use that form to write the function. So I can use f of x equals a times x minus p x minus q. So again, I'm going to use a 1 here. So x plus 1, x minus 5. So here, the function is x squared minus 4x minus 5. So in both cases here, we're writing them in standard form. We can do that using the vertex or the x-intercepts. It is now your turn. Go ahead, hit pause, do questions 5 and 6, and when you're done, hit play to check your answers. So our standard form for number 5, we end up with x squared minus 1. Now for 6, we know these are the zeros, so this is our given point. So we have 12 equals a times the quantity x minus 0, x minus 10. We replace our x values with 4, so we have 12 equals a times negative 24, which ends up with a being negative 1/2. So now we're going to use that to fill in our answers. We have f of x equals f of x equals negative 1/2 x times x minus 10 for a final answer of f of x equals negative x squared plus 5x. Now, our next order of business is to work on cubic functions, but we're going to pause for that and stop here with your turns 5 and 6. So the next few examples we will not be doing. So you are all set for today. Go ahead and start your homework. If you have any questions, please let me know.